Hello, hello, hello. Welcome to Gatewala. So, hopefully, you guys are doing well in the preparation zone. Good afternoon, good afternoon. How are you, everyone? Huh? I think all Hindi students are here. Okay. How many of you from the English category? Please tell me in the chat box so that I can recognize that is there any English student or all are the Hindi students that are present in this particular session. Good afternoon, good afternoon, good afternoon. We are in revision. Good afternoon. English, sir. Okay. No, sir. Hindi. We are Hindi. Marathi student. I am English student. Great, 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 great. So, is this series is getting very nice because at this particular time the PYQ question practice, some of the PYQ question practice are very important so that you can get a confidence that you are going to appear in the examination 25 and you will get a good confidence level that this kind of question appears in the examination. No need to worry much more by seeing some complicated, very complicated question and getting demotivated in your preparation journey. Okay, so fine, we will start today from this particular session with the first question. We will start. This is the first question that we are going to do. This is the first question that we are going to do it. See it. In this particular question, what I'm going to do, see here very carefully. There is a voltage source and resistance. There is a, noted down, all the question must be noted down. There is a voltage source and resistance. There is a dependent source, and then after there is a short point, and then again a dependent source, and here there is a resistance again. These are the values given. Okay, correct. Now the values are, I can see here the values are, that is equal to 2 kilo ohm. This is 2 kilo ohm, and this one is given as 75 volt, and this one is given as plus minus 0.5 V1. I guess yes. And this is the current, capital I, and this resistance is given as 8 kilo ohm. 8 kilo ohm, and this voltage is given as V1. This is the question that has been given to us, and this current is equal to capital I. First of all, note it down. All the question must be noted down. You are doing hard work for us. It's good motivation for us. That's great. Okay, करा दीजिए. सुपर 1500 अजय सर ने 5 क्लास में पी एंड कर दिया था. Okay, in super 1500 batch you all have requested that you need Ajay sir for the power electronics. That's why I have done that particular thing now. Okay, so in this particular question, what they are asking about, find the voltage V1. This is the actual question that has been asked. Find V1. This is the question that has been asked in the examination. It's a PYQ question. It has been asked in 2022. This has been asked 2022. Correct? Yes, sir. Now let's see how you will tackle. I have already told you, whenever you see the particular question based on the basics of network theory, always remember, first priority must be given. First priority is always KVL, KCL. KVL and KCL. Yes, this must be your first priority whenever some question you will see from the chapter number 1. By using the KVL and KCL, we will perform this particular question. So what is this particular question has been given? On that basis, what we will do, I am just making its copy. What we will do, by using KVL, KCL, we will try to solve this particular question. We have here given, this is the voltage V1 and this current is equal to how much? Capital I. Capital I. For KVL, KCL, we need to take a current in every branch. Here also I has been given to us. Now you can see we have this particular branch where we can apply the KVL. Yes sir, we can apply the KVL. If we apply the KVL, what we will get? 75 minus plus voltage rise. This will be plus minus, that is equal to voltage drop. 2 into how much? Capital I. Plus minus is also drop, is equal to 0.5 how much? V1. Na? Absolutely correct, sir. Is it okay? Absolutely okay, sir. Now this has been the equation number 1. Equation number 1. Now we have two variable 1 and 2. So what will happen? We need one more equation. Na? You can see, can I apply KVL here? No, we cannot apply the KVL here because we don't know the voltage across this particular current source. Na? But we have seen that if this is voltage V1 and this is 8 kilo ohm, then what is the value of the V1? V1 can also be written as 8 into what? I. Na? Are you getting my point or not? Yes, sir. V1 can also be written as 8 into I. Na? So what we can do? We can directly find it out. 75 is equal to 2 into I plus ka 0.5 multiplied by 8 into what? I. Na? Absolutely correct, sir. So what is the value of I? I will come out to be 75 divided by how much this value will be? This is equal to 4 and 2, 6. Na? So 75 divided by 6, that is equal to 12.5 milliampere. Na? This is the current that has been asked. Voltage it has been asked. Okay, I have just calculated I think current. Na? They have asked about the V1. Na? Okay, fine, great, no problem. If they were asked about the I current, this will be the right answer. 12.5 milliampere will be the right answer. Now they are asking about V1. So V1 will be simply 8 into 12.5. Na? So what will happen? Into 8, it will become 100 volt. Na? So 100 volt will be the right answer for this particular question. 100 volt will be the right answer for this particular voltage, Na? Correct? In this question, some more question they can also form. Na? Further possibility what they can ask. Na? You need this kind of PYQ questions or you need just solve and proceed further? What kind of analysis you want? Na? Because my procedure is this one. Na? If I have taken one question, then I will figure it out what more question they can ask about in this particular question. Na? Because I think this is the best possible way to analyze any question and doing the question. In this way, you will realize that there will be no difference in the question. It's all about how you are taking the question analysis. Na? And question analysis is always important. Na? Question analysis is always important. Na? Further possibility, if you see, you can see from here, in this particular question, you have these things. Na? This circuit will remain same and they have asked, find the P total delivered. Na? Correct? Yes, sir. So what I have told you, whenever they will ask about the P total power, whether it is absorbed, whether it is delivered, whether it is consumed, always focus on the source power. Na? Focus on the source power. Focus on the source power. Na? Source power. Na? Always remember. Na? So what are the sources? First source we have, that is equal to 75 volt. Na? So what I will do? 75 volt power, that is equal to 75 multiplied by current I is going. Na? So 75 multiplied by 12.5 milli. Na? Milli, it's a milliwatt. Na? So 75 multiplied by 12.5 is equal to, we are getting 937.5 milliwatt. Na? Now what kind of this power? This current is going from plus leaving. Na? That means it is a delivering power. Na? So it is a delivering power. Now coming to the next source, this is the source. So 0.5 V1. Na? 0.5 V1. Na? P 0.5 V1 source. Na? The voltage is 0.5 into V1 multiplied by the same current I is flowing. Na? Same current I is flowing. Na? That's great. So what I will do, I will put all the values. 0.5 into V1 we have 100 volt into 12 point how much? 5. Na? Correct? So how much it will be? It will be 0.5 into 100 into 12.5. This you are going to get 6 to 5 milliwatt. Na? 6 to 5 milliwatt. What is delivering or absorbing? You see here, this particular current is entering at positive terminal. That means it is a absorb power. Na? Absolutely correct, sir. It is a absorb power. Na? Now coming to the last one, that is the P. How much? It is a current source capital I. Na? So current source capital I. Na? Absolutely correct, sir. Now you see, you have this current value. Na? but you don't have the voltage across that current source now. So what I will do, I will take some voltage across that current source now according to my convenience now. If you see, if this is a short point, that means it is a 0 volt na? Absolutely correct, it is 0 volt. Now you assume some voltage, whatever you want to assume, you assume it na. I have taken plus minus like this one and taken it as a V2 voltage na. Absolutely correct, sir. Now apply one KBL here. If you apply the KBL, this is plus minus drop and this is plus minus drop. That means V2 is equal to how much? Minus ka V1 na. Minus ka V1 na. So what I will do, V2 and V2 is equal to how much? Minus V1. So just put all the values. This will be 100 into 12.5. This will come out to be 1250 minus milliwatt. Absorbing or delivering? Check it. It is absorbing, delivering. It is absorbing na. So what I will do, this is absorbing power na. You can write it down, plus 1250 milliwatt delivering na. Yes sir. Now we have all the things na. All the things na. If we have all the powers, what is the value of P total delivered? P total delivered will be equal to, just see what I have just in the what I have done in the Maha revision section, that just see which are the powers are positive delivered. This is positive delivered, yes sir. This is positive delivered, yes sir. Is this positive delivered? No, it will be minus delivered now. So these two add it on now. So 1250 plus 937.5 is equal to how much it will be? Plus 937.5. This is equal to 2187.5 watt. Now this is the right answer for this particular question. This is the right answer for this particular question. Now you can see, if this is P total delivered, this power is absolutely equal to P total what? Absorb also. This power is also equal to P total consumed also now. Correct? Yes sir. Now if they have asked, find the P total dissipated. Find the P total dissipated. If they have asked, then what I have told you, write down the total power. Total power we have 2187.5 milliwatt minus whatever the source is absorbing positive, just minus it now. If I minus it, 625 watt now, 625 milliwatt, then what we have, that is equal to minus 625, we have 1562.5 milliwatt. This is the dissipated power. Are you getting my point? Have you got the answer for this particular question? So in this question has been asked only one, but what we can do, we have framed 2-3 more questions, so that if the circuit will come like this one and you need to calculate all these things, you can calculate very easily. Now coming to the next question. The next question is what? The next question you can see, I can see in this PW book, that is given as there is a voltage source plus minus 6 volt. There is a resistance. There is another resistance. That's good. There is a resistance and there is a current source. Great. And there is a resistance and there is a dependent source like this one. This is good question. Na? Plus minus beta Vx. Na? And where is the Vx? Vx is equal to this voltage is the Vx. Na? That's cool. Next, here it is given as plus minus what? Vy. And it is given as 2 ampere. It is given as 3 ohm. It is given as 2 ohm. And it is given as 1 ohm. Na? Correct? Note it down. Please note it down. Please note it down. Please note it down. You teach in Vijay. Just like same, you teach in Vijay. Exactly. Correct? Please see this one. Please see this one. Note it down. What the question is asking, this question has been asked in 2021. 2021 this question has been asked. It is saying that if Vy value is equal to 0 volt, then find the value of find the value of beta. Na? It is asking about the beta value. What is the value beta they are asking? Na? Yes, beta they are asking. Na? Now, again, the question is from what? Network theory. It is basic of the network theory. So what I have told you, our top priority will be what? Our top priority will be what? KBL, KCL. Na? KBL and KCL will be our top priority. Now, always practice one method as much as you can practice. Na? Then that is going to be helpful for all of you. Otherwise, it is not going to be helpful for anyone. Na? So, what we will do? We will apply simply the KBL and KCL. Na? So, what I will do? I will do in this particular question. First of all, it is saying that Vy is equal to 0. Na? So, make it 0. Make it 0. Na? No problem. I am just making it 0. So, if this voltage is equal to 0 volt, na, it is given to us. Na? That's cool. If it is 0 volt, you see here, if it is 0 volt and this is the plus minus what? Vx. Na? Absolutely correct, sir. Now you see, this is beta Vx. Here it is a 2 ampere and here it is a 6V. Now, where is the Vx? Yes, Vx is given here. Na? Now, how we can solve it? Na? How we can solve this particular question? Can I apply the KBL here? No, we cannot apply the KBL. If we can found the value of what? You can see, we need this particular current. We need this particular current. Na? These two things we needed. Na? Otherwise, it's very complicated. It will become very complicated. Na? You can see very carefully. If this terminal is A and if this terminal is B, you can see this is also B. If it is 0 volt, that means if it is 0 volt, that means this terminal will also be B. So A to B voltage is Vx. So this voltage will also what? Vx. Na? Absolutely correct, sir. And this current will be how much? This resistance. This resistance is 4 ohm. Na? This is 4 ohm. This current will be Vx by 4. This current will be Vx by 2. Na? Absolutely correct, sir. If these two currents are there, what about this particular current? This current will be how much? This current will be Vx 1 by 4 plus 1 by 2. Na? Absolutely correct, sir. Now apply the KBL. You will get the value of Vx first. Na? What we will get? 6 is equal to, this is plus minus drop, 1 multiply. So Vx into 1 by 4 plus 1 by 2. That's cool. Plus minus, that is equal to Vx. Absolutely correct, sir. So what is happening? Here we will get Vx. This will be into, this is equal to 4 plus 1, 4. Here it will be 1 plus 2 and plus Vx. Na? Absolutely correct, sir. Vs I am taking it common. So Vx will be common. We have 3 by 4 plus 1 and that is equal to Vx into what is 7 divided by 4. Na? So what is the value of Vx? Vx we will get, that is equal to 4 into 6 divided by 7. Na? That is equal to, we are getting 6 into 4 divided by 7. We are getting 3.4285. Na? Are you getting my point or not? Yes, sir. Vx we are getting how much it is? That is equal to 3.4285. Na? This is the value of Vx we have got it. Na? Now you can see, if we have Vx value, then we have everything. Na? If this current, we know that this is the 0.5 Vx and this is the 2 ampere. What about this particular current? This current will be incoming, outgoing. 2 plus, how much it will be? 0.5 Vx. Na? Absolutely correct, sir. Is it correct? Yes, sir. Now apply the KBL in this particular loop. If we apply the KBL in this particular loop, what we will get? We will get the answer directly. Minus plus 0 volt plus minus it will be drop and plus minus it will be drop. So beta Vx plus 3 multiplied by 2 plus 0.5 watt Vx is equal to how much? 0. Na? Yes, sir. Absolutely correct, sir. Now tell me, you can take beta Vx plus, this will be 6 plus 1.5 into Vx is equal to 0. Na? So we have Vx bracket, this will be beta plus 1.5 plus 6 is equal to 0. Are you getting my point? Yes, sir. So beta plus 1.5 into Vx is equal to minus 6. So beta plus 1.5 is equal to minus 6 divided by Vx. So beta is equal to minus 6 divided by Vx minus 1.5. Na? Yes, sir. Just put all the values, you will get your answer. So Vx we have got it. Na? Vx we have this value. This just taking it inverse into 6. This is coming to be 1.75 plus 1.5. So we are getting minus 3.25. This is the value of what? Beta. Minus 3.25 will be the right answer for this particular question. They are asking about the beta value. If you know the beta value, now you can do whatever you want to do in this particular circuit. Now you have all the authority to do whatever you want to do in this particular circuit. Now you can also calculate the power also. Now all the power you can calculate it. Now here you have seen that. Now how you can calculate the power? You know the Vx value, you know the current, you can calculate the power of this one. You know the voltage, this power will be 0. You know the voltage, now beta, Vx, both you know. This voltage you know, this current you know. You can find this particular power also. So you can find the delivered power. You can find the dissipated power. You can find everything if you have two values, that is the beta and Vx value in this particular question. So just believe on the one method. Try to apply the number of times KVL and KCL, then only you will succeed in the examination. I am telling you every time. I am telling you repeatedly, then only you will succeed in the examination if you have practiced much more on the single method. And in every batch I have told that one method just conquer that particular method. Now coming to the next question. See what is in this particular question. In this question, they have given, first of all, see, it's a very easy question they are asking every time. See, they have given, there is a voltage source plus minus 25 volt. I have selected some questions only, so that you can understand that your preparation is at very good level. Need not to worry too much. 17 volt, this is the R1, and this is what? This is the capital I value. And here there is a resistance again, correct? And there is a dependent current source, like this one they have given. And here 0.4 I, and this value is equal to R2. And this current is also given as 14 ampere. Wow, everything they have given. This is 25 volt, this is I. They are saying that if 25 volt is supplying how much power? Is supplying this watt power in the circuit. In the circuit means what? The power you need to calculate of the 25 volt. They are asking about this particular power. Now come to this question. In this question, again, you need to calculate for the power, voltage and current. So what I will do, I will prefer the KVL and KCL again, and we will calculate the power. You see here, if this current is capital I, then what will happen? The power of P25 volt will be equal to 25 multiplied by capital I. That means we need to calculate only the current capital I. Where is the capital I? You can see this current is given as 14 ampere. And this current is equal to given as 0.4 capital I. Absolutely correct, sir. Now just apply the KCL here. If you apply the KCL, this is incoming current, capital I. This is incoming current, 0.4 I. And this is the outgoing current, that is equal to 14 ampere. So I will be equal to 14 divided by 1.4. Absolutely correct, sir. That is equal to 140 divided by 14. That is equal to 10 ampere. It's question is over. So 25 multiplied by 10, that is equal to 250 watt. Whether it is delivering? Yes, sir, they are delivering. Correct. It's a 250 watt answer. So such kind of question you will see also in the examination. And it is not a very old question. This is 2018 question. Are you getting my point? So some questions you will see like this one also. So need not to worry too much. You are at a very nice position. Okay. What kind of power they have asked? They have asked the supplying. Na? Supplying means delivering power. Na? If they have asked absorb power, then what should be your answer? Minus 250 watt. Na? Minus 250 watt. Na? Absolutely correct, sir. Now one more question. One more question they can ask in this particular circuit. They can ask about find the value of R1 and R2. Yes, they can ask it. Now you can see the value of R1, how you can directly calculate. How? See here. If this particular voltage you know that and this current you know that, so R1 will be 17 divided by I, na, simply 17 divided by capital I, na, and capital I you have calculated, that is equal to 10 ampere. So 17 divided by 10, that is equal to 1.7 ohm. Na. R1 is done. R1 is done. Now if they have asked find the value of R2, you know the current, na, but you don't know the voltage. Na. So what I will do, I will take a voltage like this one and I will see like this one V2. Na. If we calculate the voltage value, we will get the answer. So can I apply the KVL here? Yes, we can apply the KVL. If we apply the KVL, this is minus plus 25 and this is 17. So V2 we have 25 minus 17. Na? Absolutely correct, sir. So what will happen? That is equal to 8 volt. Na? V2 is equal to how much? 8 volt. Na? Then R2 will be directly equal to how much? V2 divided by 14. So 8 divided by 14. So how much you are going to get it? 8 divided by 14. Na? 8 divided by 14, that you are getting 0.5714 ohm. Na? This is the R2 value that you can calculate very easily. Na? Very easily. Na? There is nothing like that. In this there is some problem you are going to face it. Na? No problem you are going to face it. Na? Be very, very careful. Now coming to the next question. Coming to the next question that we have. See here. This question has been asked in 2017, I guess. Okay. There is a circuit. Okay. There is a voltage source plus minus. There is another resistance. And there is another dependent source. Na? Like this one they have given. So this is a K times of V0. And here there is a resistance. And here they have given a current source of 5 ampere. Na? This is a 5 ampere current source. Here they have 5 ohm. Here they have, the resistance is not mentioned here, 2 ohm. And here they have 4 volt. Na? This is plus minus V0. Na? They are asking about if K is positive and power dissipated in 2 ohm is 12.5 watt, then find the value of K. Na? Find K value. Na? They have asked this particular question. Once check it, this middle resistance is not given. I have to check it whether it is given or not. Na? One more time. It's a 10 ohm. Na? It's a 10 ohm given. Na? It's a 10 ohm beta. It's a 10 ohm. Correct? Yes. Do it. Try at least once, na, by yourself. This is again the 2015 problem. Na? They're asking about the K value. They have already mentioned that K is a positive number. Na? It can't be a negative number. Na? That's cool. Again, think about the KVL and KCL. Just think about the KVL and KCL. Nothing else. Na? So what I can do? How we can solve this particular question? How we can solve this particular question? How we can solve it? Think about how we can solve this particular question. Think properly. They have given, see here. You need to find the K value. Na? Okay, fine, great. We will see na, what we can do. We will think about KVL and KCL. Na? I'm again and again telling, think about KVL and KCL. Na? Just think about KVL and KCL. Just see what are the currents has been given. This particular current is given, that is equal to 5 ampere. Na? That's cool. And this particular voltage is given V0. Na? Okay, fine, great. Now, one more thing they have given. If you see, this particular current you can calculate directly. Na? How we can calculate this particular current? They have given let's take it I1 current. Na? So I1 square into 2, they have given 12.5 watt. Na? They have given, na? Yes sir, they have given 12.5 watt. Na? So what is the value of I1 you will get? I1 value you are going to get 12.5 divided by 2 root. Na? So how much value you are going to get? We are going to get 12.5. This is 12.5 divided by 2. This one and this square root 2.5 ampere. Na? 2.5 ampere. Na? Absolutely correct, sir. Now we know that this current is 2.5 ampere. And this current we know that 5 ampere. So just apply one KCL here. This is the incoming current. So KV0. That's cool. This is outgoing current. This is incoming current. So plus 2.5 is equal to how much? 5. Na? So KV0 is equal to 5 minus 2.5 means minus 2.5. Na? So K value is equal to how much? Minus 2.5 divided by V0. And you can see the V0 is equal to current multiplied by resistance. That means 5. Na? So minus 2.5 divided by 5 is equal to minus 0.5. This is the value of K that you are going to get it. But what they have asked you, they have asked, see very carefully, you have calculated this value. Whether it is a right answer or wrong answer, this is absolutely wrong answer. Why wrong answer? Why it is wrong answer? Because if you see this particular, whatever this particular K value is coming, this is coming negative value. This is coming negative value. Na? They have clearly mentioned that K cannot be negative. Na? It is a positive value. Na? Then where some mistake has been done? You can see here. Now you have to take care. Na? Maximum student will write the answer K is equal to 0.5. Na? They will see negative, no problem. I will write only 0.5. Na? But this is wrong answer. This is absolutely wrong. Now you see. Now how you can, because this is wrong as K is greater than 0. That's why it is wrong. So what we can do? You can see here. This I1 is a root square of what? 12.5 divided by 2. That means you will get it here plus minus 2.5 ampere. If you have taken positive value, then you are getting a negative value of the K. Now take it as negative of 2.5 ampere. Now. So what I will do? I will take the negative of this particular value. Now. So I will take negative of this particular value. Now. So I will be equal to minus 2.5 how much? Ampere. Na? Absolutely correct, sir. Now apply the, again, how much beta? I have done some mistake. Okay, it is my fault. Calculation mistake. Okay, no problem. Then it's fine. Then it is fine. Na? Then it is fine. That means, okay, this is coming now. Okay, fine. Great. Then great. Then 0.5 is okay. Then 0.5 is okay. Na? Then need not to do this particular thing. Na? Need not to do this particular thing. Okay, no problem. 0.5 now. Then it's cool. 0.5 is the right answer. Okay. I didn't see that. Na? Okay, great. See, I am a teacher and I just focus on the question. Na? They have said that we cannot afford the negative value. So I am just searching for, we have to take the positive value. That's why I have taken it there. And we have started the new solution for this particular question. Okay. Now it's good. If you have got this particular thing, there is no problem. It's absolutely correct one. Na? There is nothing wrong in this particular question. Na? Are you getting my point or not? Yes, sir. Absolutely. It is cool and great. Na? It's a 0.5. Na? So K value, how much we are getting? Shall we check the answer? 0.5 is the right answer for this particular question. Now, coming to the next one. Na? What is the next question? See here. The next question is, this is again a good question. Na? What is the question? See here. There is a resistor. There is another resistor. There is another resistor. There is another resistor. there is a current source, there is a another resistor, and here it is a current source, like this one. What are the values? The values are 1 1 1, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Here it is given 1 ampere, 2 ampere, 1 ampere, and it is 2 ampere. And here they have given there is a 10 volt source, plus minus 10 volt. And they are asking about find the power supplied by the voltage source. Power supplied by voltage source. Find power supplied by voltage source. There is only one voltage source. Correct? Yes. What is the timing of Mahabhyas? It's a 7. It's a 7. It's a 7. It's a 7. Okay, 7 p.m. Now in this particular question, they are asking about the 10 volt power. If you want to calculate the power in the 10 volt, you need to calculate the current in this particular system. Yes, sir. We need the current. So how we can do that? Think about again KVL and KCL. Just think about KVL and KCL. So if I'm thinking about the KVL and KCL, what we will see here? See, we need the current in each and every branch. You can see, if this is the 1 ampere, this is the 2 ampere. Can I say that this is 3 ampere? Yes, sir. This is 3 ampere. We do not know about this current. We do not know about this current. So let's take one. You have to assume current. So I'm taking it as a I current. If it is I current, then what will happen? What about this particular current? This current will become 3 minus I. 3 minus I, absolutely correct, sir. This is the 3 minus I current, absolutely correct, sir. This current is 1 ampere. This current is this one. What about this particular current? What you will see? You will see if this is capital I and this is the 2 ampere current. What about this current? This current will become I minus 2. Now we know that all the current in every branch. All the current in every branch. If we know the current, then we have everything to do that. We need to calculate this current. Now we need applying KVL. Can I apply the KVL in this loop? No, because we don't know the voltage across this one. Next, can I apply the KVL here? No, because we don't know about the voltage across this one and across this one. Can I apply the KVL here? No, because we don't know about the voltage across this one. But if you see this particular external loop, you can apply the KVL. Why we can apply? In this loop, big one. So if you apply, this will become plus minus, 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 and this will become plus here and minus here. Apply the KVL. Plus minus drop. What I will write? 1 plus 2. Both are same current. 2. Directly I am writing 2 into how much? I minus 2. First one is done. Both is done. Now minus plus, this is voltage rise. This is voltage rise. This is voltage rise. So these two will be 2 into how much? 3 minus I. This is voltage rise. Next one plus minus drop. Plus ka 10. That's cool? Yes, sir. Equal to. So how much it will be? 2I minus ka 4 plus ka 10 is equal to 6 minus ka 2I. Absolutely correct, sir. 2I will come out here. 4I is equal to, this will be 6 plus 4 minus 10. That means I is equal to 0 ampere. If I is equal to 0 ampere, then P 10 volt will be equal to 10 into 0. That means 0 watt. Absolutely correct, sir. So 10 volt is supplying just only 0 watt power. How much power it is supplying? It's a 0 watt power. That means it is neither supplying or neither absorbing the power in this particular circuit. Then if in this particular question they can ask much more things also now. They can ask about the power of this one, they can ask about the power of this one. Now you calculate each and every power now, because you know this particular current I value 0, that means you know this voltage, you know this voltage, you know this voltage, you can calculate this voltage, you know this voltage, you know this voltage, you know this voltage, you can calculate this voltage also now. So whatever the power they will ask, now you can calculate very easily, because you know the value of I, and I is coming to be 0 ampere na. Is it correct? Yes sir, absolutely correct one na. Great. So I think in this question also you will rock it, and there will be no problem in this particular question also. You all will do in the best in this particular question also na. Next we will move to the next question. We will move to the next question. The next question, so most probably in the first chapter they will ask about the power questions, they will ask about the current and voltage calculation, such kind of questions they will ask na. Now coming to the next question, this is 2020 problem na. It is given that there is a current source, okay, and there is a resistor great, and there is a voltage source plus minus, and there is a resistor, and there is a current source, yes sir, like this one, and there is a another resistor, there is a another resistor, and here it is a written as plus minus VTH, correct? Now this is 2 ampere, this one is given as 2 ohm, this one is given as 4 ohm, this one is given as 2 ohm, and this one is given as 2 volt, and this one is given as 1 ohm, and this one is given as 1 ampere, correct? They are asking about find the VTH na, find VTH na. I am just adding RTH also na, both you will find na. Please do it, please do it everyone. I am just asking, please do it. You need to calculate the VTH na. Yesterday in the Maha revision I have told you how to get the VTH value. Just open the terminal, it's already open na? It's already open. Now just apply the KVL and KCL, you will get your answer, that's it. You will get your answer, that's it na. I will apply only one method in 99% of the problem na. I will not go with the nodal, I will not go with the any other method na. I will apply the only single method na. So what I will do, if you want to calculate the VTH, then how you will calculate it? It's very simple to calculate. You know that VTH means open circuit terminal, that means this current will become 0 ampere now. If this current is equal to 0 ampere, that means this voltage is also 0 ampere, 0 volt, yes sir. If this current is 0 ampere, that means this is 2, this is how much? This is equal to 2 ampere na? Absolutely correct sir. Now you tell me, this is 2 ampere na? Yes sir, okay, fine, great. This is 1 ampere na. Now you see how you can calculate the VTH value. There are two methods na. You can apply the source transformation, phalana dhamaka things, okay? Or you can go with the simple KVL and KCL, that's it na. So what I will do, I will figure out with the KVL and KCL na. You can see this is 1 ampere, this current and this current you don't know na. If you don't know this particular current, can I say that I'm just taking it this current as a I current na. If it is I current, then what about this current? This will become 1 minus I current na. Absolutely correct sir. This current will be 1 minus I current na. Absolutely correct sir. Now tell me, if this is 1 minus I and this is the 2 ampere, what about this particular current? And this current and this current, both current will be same. How much current it will be? 1 minus I plus 2. If you do the plus 2, this will become 3 minus I current na. Absolutely correct sir. This will become plus minus, this will become plus minus, and this will become plus minus na. Done. Question is done now. Question is done now na. Now you can see what I will do. I have just figured out all the current in every branch na. Now we need to apply the KVL na. How we can apply the KVL? We can apply the KVL in this loop na. Yes sir. You see, yes sir, in this loop I can apply na. Yes sir. Minus plus voltarize, how much? 1 into I. Next, minus plus voltarize, that is equal to 2. Plus minus drop, 2 into how much? 1 minus I. Great. Plus minus drop, how much you are getting? That is equal to 3 minus I multiplied by how much? 2. Na? That is equal to that is equal to how much? This. Na? That is equal to this much. Na? So calculate it. 2 plus I is equal to, here you will get 2 minus 2I plus this is equal to 6 minus 2I. So this will become 4I and 4I will come out here. 5I it will become. Here 2 will be cancel out. You can see 2 cancel out. So what we will have? 6. Na? Here 6. So I value you are getting 6 divided by 5. Na? That is equal to 5 and that is equal to 1.2. Na? 1.2 ampere. Na? That's cool. This is the value of I. You have got it. Na? Please reason, sir. This loop, see, why you cannot take this particular loop? See, you know the voltage here, 1 into I, you know this voltage, you know this voltage, and you know this particular voltage. So you can apply this particular loop, na dear? You can apply this particular loop. There is no problem in that. Okay? So you have calculated I value by doing the KVL. Now what is the VTH? See here, if it is 0 volt, then VTH will be equal to this voltage. Na? Yes, sir. So VTH we can directly write down 2 multiplied by how much? 3 minus I. Na? So 2 into 3 minus how much? 1.2. So how much value you are going to get it? Just where is the calculator? Yes, we have got 3 minus 1.2. 1.8 into 2. You are getting 3.6 volt. Na? This is the right answer for the VTH. Sir, I did source. You can do it source transformation, no problem. But why I will do the source transformation? Why I will make it complicated? Na? I will not make it complicated. Why? Because there is no need of all these things. Na? You know that, just see, there is only one variable you are getting, na? I only. Na? So what I will do? I will take I current, I will take in this loop and just apply the cable. You will get I and you will get the VTH value. Na? Are you getting my point? Yes, sir. So think about single method multiple time. Na? You can apply the KVL everywhere if you have a variable limited to 2. Na? If the variable is increasing more than 2, then only think about something source transformation, something about nodal, something about different methods. Na? But if you have limited to the 2 variable equations, then try to apply the KVL and KCL. That is going to be the best possible option for all of you. Okay, great. So VTH we have got it. Na? Now they are asking about RTH also. Na? If you want to calculate the RTH, what I will do? Which case it is belonging? This is the case number. Which case it is belonging? It is belonging RTH. This is the case number 2 problem. Na? If it is case 2 problem, independent sources will be deactivated, so it will be open. This will be short and this will be open. This will be short and this will be open. This will be open. Na? Perfect. So you can see these two has become now series, that is equal to 3 ohm, and this 3 ohm is parallel with 2 ohm. So 3 into 2 divided by how much? 5. Na? So this will become 6 by 5. Na? That is equal to 1.2 ohm. Na? Now this 1.2 ohm is series with 4. So RTH will come out to be 4 plus 1.2, that is equal to 5.2 ohm. Na? That's it. This is the RTH value. Something I get confused. So I use different method apart from KCL, KVL. So I use, yes, no problem, no problem. There is no problem in that. There is no problem. But try to figure out IIT and 100. Try to figure out. Just start thinking about the KVL, KCL. Definitely, I'm damn sure in maximum cases you will get the answer. In maximum cases, and with the easy approaches, na? With the easy approaches, na? Next, coming to the next one. So I have calculated VTH and RTH also here. Na? Coming to the next question. This is good question. Na? See, this question has been asked in 2017. This is given as, this is good question. Na? See, just see here. There is a dependent source like this one. There is a resistor here. Absolutely correct, sir. And here there is a resistance also. And here there is a voltage source, na? Plus minus like this one. And here there is another resistor. And here there is another resistor. And here it is given the terminal named as PQ. Correct? This is the 1 ohm, 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 this is given as 10 volt, this is given as plus minus 3 I0, and this current is equal to I0. Correct? They are asking about, it's very easy thing, they are asking about find RTH across PQ terminal. PQ terminal. Are you getting my point? Yes, sir. They are asking about the RTH at PQ terminal. Na? शाम को मिले रजत ठाकुर, ठीक है, okay, no problem. चलिए, they are asking about the RTH value na across PQ terminal na. So what we need, we think about the our cases, case 1, case 2, case 3, case 4. So what about the cases? Here it is given, this is the RTH belongs to case number, which problem? Case number 3 problem. Na? It is case number 3 problem. Na? Case number 3 problem means having independent source, having dependent source, and resistive network. Na? So which method we will apply? We will apply the test voltage approach. Na? Test voltage approach. Na? What is the test voltage approach? In test voltage approach, what we will do? We will just apply 1 volt source. In test voltage approach, what we will do? We will apply 1 volt source. So applying the 1 volt source here. This is 1 volt source plus minus 1 volt. Next, this current I have taken capital I. And now this independent source will be deactivated. So it will be short circuited now. Correct? Yes, sir. This is the test voltage approach that we need to apply. Now you can see, if it is a 1 volt, now you need to calculate this capital I. Na? Start thinking about the KVL and KCL. So we need to have the current in every branch. Na? See here, if this is the I0 current, you can see this volt and this volt will be same. This is also 1 volt. So this current will become 1 ampere. Na? So I0 has become 1 ampere. Na? If it is 1 ampere, this will become 3 into 1, that is equal to 3 volt. Na? Are you getting my point? Yes, sir. Absolutely getting my point. If this is the 3 volt, then this voltage will also be 3 volt. And if this is the 3 volt, then what will happen? This current will be 3 divided by 1, that is equal to 3 ampere. Na? Are you getting my point or not? Yes, sir. Now, see here. This is the 0 volt, then this voltage will also be 0 volt. If this is the 0 volt, this current will be 0 ampere. Na? Absolutely correct, sir. Are you getting my point? What I'm trying to say? Yes, sir. Absolutely getting a point, sir. Now, see here again. See here again. If this is 1 ampere and this is the I current, na, capital I, what about this particular current? How much current it will be? This current will become, this is 1, this is I, so this will become 1 minus I. This will become 1 minus I. This is, here it is 0, so this will become 1 minus I. This will become 1 minus I current. Na? Absolutely correct, sir. You need to calculate I. Na? There is only one variable is given. Na? So just apply the KVL here. You will get your answer. Just do na 1 KVL here. What I will get? I will get, this will plus minus. This will plus minus. Okay. Plus minus drop 1 into 1 minus capital I. Next, it is 0. Minus plus voltage rise. Minus plus voltage rise, that is equal to 3 volt. Plus minus voltage drop, that is equal to 1 volt is equal to this. So this will become 1 minus I plus 1 is equal to how much? 3. So I will become 2 minus 3, that is equal to minus 1 ampere. Na? Are you getting my point? Yes, sir. I is equal to how much you are getting? Minus 1 ampere. If it is minus 1 ampere, then what about the RTH? RTH will be 1 divided by capital I, 1 divided by minus 1. So RTH you are getting minus 1 ohm. So minus 1 ohm will be the right answer for this particular question. Minus 1 ohm will be the right answer for this particular question. I have to check the answer whether it is correct or not. I think this is correct. No? This is absolutely correct, dear. This is absolutely correct and absolutely fine. Okay. Have you got it? So I'm coming to the next question. No? Okay. this is -1 ampere is the right answer for this particular question. Now coming to the next question. This question has been asked in 2021. What is given here? It is given here, there is a current source, there is a resistor, okay, and there is a dependent voltage source, and there is a resistor again, and this is the terminal AB, and here it is given 2 ohm, it is given minus plus 3I1, and here it is given I1 current, and this one is given 10 ohm, and this particular one is given 5 ampere. Note it down. Please note it down. Please note it down, everyone. Yes, if it is a PYQ question, then definitely it will be present in your book also, na? If it is PYQ question, then definitely it will be present in your book also, na? Obviously. See, what is given? This particular question, it has been asked in 2021. They are asking about find the VTH and RTH. Na? Find VTH and RTH. Na? They are asking both things. Na? So what I will do? First of all, we will do the VTH. Na? So first of all, we will do VTH calculation. Na? So what is the procedure for VTH? Nothing. Just take it here. This is the VTH. If it is VTH, open circuit, this current will become 0 ampere. Absolutely correct, sir. If it is 0 ampere, this voltage will be 0 volt and this current will be 0 ampere. Na? Absolutely correct. If it is 5 ampere, you can see here, if it is 0, then I1 will also be equal to 5 ampere. Na? Correct, na? Yes, sir. If I1 is equal to 5 ampere, this will become 3 into 5, that is equal to how much? 15 volt. Na? You can see this kind of question they will ask also. Na? Okay. So in this question, if somebody is missing and they are getting the wrong answer, that is bullshit. Na? Now tell me, this voltage, how much it will become? This will become plus minus 50 volt. Just apply 1 KVL here, you will get your answer. Minus plus voltarize 50, minus plus voltarize plus 15. This is 0 plus minus drop, that is equal to VTH. So VTH, we have directly got it 65 volt. Na? Absolutely correct, sir. This is the PYQ question. Okay, 65 volt. Na? Are you getting my point? Yes, sir. This much of, but never ever get overconfidence na? By seeing the question. Na? In overconfidence, definitely there is a high probability of doing mistake in the question. Na? So never ever get overconfidence. If you see some easy question, then don't get overconfidence. Na? Okay, this is very crucial for all of you. Okay, now coming to the next one. What about the RTH? How you will see the RTH? Na? If you want to calculate the RTH, then you need to figure out which kind of category of problem this one. So this is belongs to RTH. This is the case number 3. Na? This is again case number 3. If it is case number 3, then what I will do? I will use the test voltage approach. So here I will connect plus minus 1 volt. And this current I will take it capital I. Na? Absolutely. And where is the independent source? Just open it. Na? Deactivate it. Yes, sir. Now the circuit will become like this one. You need to calculate this particular I value. Na? So how you can calculate it? You can see from here, if this current is I1, this is I1, and this current is equal to capital I, that means I1 and I is same. Na? This is also 3 times of I. Na? Correct. So this is I current, so this will be plus minus this one. Na? Just apply 1 KVL here, you will get your answer. Applying the KVL, this will become plus minus. So minus plus voltarize 10 into I. Next, minus plus voltarize plus 3 into I. Minus plus voltarize plus 2 into I. This is plus minus drop 1. So what you will get? I take it common. So 1 divided by I is equal to, directly you are getting 10, 3, 15. And 1 by I means RTH. So RTH directly you are getting 15. Are you getting the point? Yes, sir. ज़्यादा खुश होने से गेट, हाँ ये होता है जब क्वेश्चन देखो कई बार ना बहुत खुशी मिलती है, तो उस केस में दिक्कतें होती ना. Okay, so don't get overconfident whenever you see some easy question in the examination. Okay, so RTH we have got it here na. RTH we have got it here na. So hopefully you all have understood how you have calculated these things na. Now coming to the next question. Question is always simple beta. Okay, question is always simple. You need to just understand things. That's it. Okay, so here it is given, there is a voltage source plus minus, there is a resistance, R, okay, and there is a voltage source like this one. This is plus minus this one, and there is another resistor here like this one. There is another resistor here like this one, and there is a current source na, downward direction. The values are given 2 ampere. This is given 5 ohm. This is 6 volt. This one is given 3 ohm. This one is given R. This one is given 5 ohm. This one is given 5 volt. What they are asking? They are asking about maximum power transferred. Means find the max power transfer to the R. Are you getting point? That means you need to calculate the maximum power that is going to be transferred into the resistance R. Now you see very carefully. Here you tell me R is a variable quantity. Na? R is a variable quantity. If it is a variable quantity, that means we can apply the MPTT theorem. Na? So here we can say that na, we can apply the MPTT theorem. Na? So here we have all the right to apply the MPTT theorem. So we can apply the MPTT theorem. Na? Yes, sir. So what we will do? Here we will apply MPTT. Na? Correct? For MPTT theorem, you need to find the VTH and RTH because they are asking about the maximum power. So we need VTH and RTH both. Na? So what I will do? First of all, we will calculate the VTH value. Na? So what about the VTH? If you want to calculate the VTH, just open this particular terminal. Just mark it here, plus minus VTH. Na? Now tell me how you will calculate the VTH value and how you can solve this particular question. Na? Do it. Do it. Think about and do it. It's very easy. Na? Think about what? KBL, KCL. It's very simple. See here, if you see this current, you know that na, this is 2 ampere. Okay. You don't know this particular current, you don't know this particular current. Now both current you don't know. So just make it one current. You can apply one current, no problem, sir. So if you, I will just take it as a capital I current here. Na? So this will become capital I. Na? If it is capital I current, you can see here, this is 2 ampere. This is I, this is 2 ampere. So this will become I plus 2 ampere. Na? Yes, sir. This is I plus 2, I plus 2, I plus 2. Here also I plus 2 ampere. Na? Yes, sir. This will become plus minus. Na? Now you can see, we can apply things and we can find the value of I. See here. Now we can apply the KBL in this loop. Na? This loop. I can apply. Na? Yes, sir. So what will happen? Minus plus 5 volt. Plus minus drop. Minus plus this is also. So plus 6 volt. Plus minus drop. Plus minus drop. So this will become 5 into I plus 2 plus ka 5 into how much? Capital I. Na? Absolutely correct, sir. So what will you will get? This is 11. This is 5 by plus ka 5 by plus ka how much? 10. Na? So this will become 10I is equal to 11 minus 10, that is equal to 1. So I is equal to, we will get 1 divided by 10 na? Ampere. This is the value of I that we are getting here. Na? Value of I getting here, that means 0.1 ampere. Na? 0.1 ampere, this is the value of I we are getting. Absolutely correct, sir. Now we need to calculate the VTH. Na? So VTH, we can apply the cable here or we can apply the cable here also. Anywhere we can apply it. Na? If you apply here the KVL, what will happen? What will happen? See here, minus plus volt rise 5 volt. This is drop, this is drop. So VTH plus, how much it will be? 5 into I plus 2. Na? So this will become VTH is equal to 5 minus 5I minus 10. Na? Yes, sir. So this will become minus 5 minus 5I. Na? So minus 5 minus 5 into 0.1. So it will become minus 5.5 volt. Na? So this is the value of VTH. Minus 5.5 volt will be the VTH value. Be careful. Okay. Minus 5.5 volt will be the VTH value. Na? Absolutely correct, sir. Now tell me, what about the RTH? What about the RTH? So I will calculate what? RTH value also na here. So to get the RTH value, we will go with the cases. You tell me, here we need to calculate the RTH. Na? This is the case number RTH. Na? Yes, sir. This is the case number which? Case number 2 problem. It is case number 2 problem. Na? If it is case 2, I will make it short. I will make it short. I will make it open. Na? Yes, sir. So what I will do? I will make it short. I will make it short circuit. Na? Correct? This is open circuited. Yes, sir. So if you do, what will happen? If this is shorted, this 3 ohm will also be shorted. There is no use. This will become only 5 ohm and this is 5 ohm. So RTH will be simply the parallel combination of 5 into 5 divided by 10. That is equal to 2.5 ohm. Na? Yes, sir. This is the RTH value, 2.5 ohm. Now, what is the value of PR max? PR max, that will be equal to VTH square divided by 4 RTH. VTH we are getting negative of this one. If you do the square, you will get the positive value. VTH, how much we are getting? VTH, where has been? VTH minus 5.5 it was, na? Minus 5.5 square divided by 4 into 2.5. How much it will be? It will become 5.5 square, this divided by 2.5 into 4, you will get 3.025 watt. Na? This much of the maximum power. Na? 3.025 watt. Correct? Yes, sir. Are you getting my point or not? Yes, sir. This is the value of VTH and this is the value of what? RTH. You have got it and you have figured out what condition you can take it. Na? So for maximum power, they can ask also about what is the value of RS. So RS will be equal to RTH. Na? RTH we are getting 2.5. So RS and RTH will remain same, na? To get the maximum power in the RS value. Is it okay? Yes, sir. Absolutely fine, sir. If there is any problem, you can tell me. Is there any problem? You can tell me. Okay. Anyone have problem with the negative VTH that you have got it? If anyone is getting problem that we are getting negative VTH, is anyone facing the problem with this one? You can tell me. You can tell me. There is no problem. I will explain it. If anyone have doubt that VTH we are getting negative, so what is the meaning of this negative one? Na? If anyone have doubt, you can ask me. I will tell you. Someone get confusion, na, that VTH we are getting minus. Na? Is there any doubt? No doubt, na? So that is fine. Okay, no problem. Now, coming to the next one. Coming to the next one. See. Question. Next question you can see. Here, we have been given there is a resistance and there is a dependent source. Na? Okay. And there is a resistor here also. Na? And there is a resistance here also. Na? Yes, sir. and here there is a terminal given, and here also there is a terminal given, and here it is written plus minus V1 and this is I1, okay, and this is given 3V2. This is plus minus V2 and this is the I2 current, and the resistance value is given 1 ohm, 1 ohm, 1 ohm, and this is the 1 ohm and this is the 1 ohm. They are asking about find, there are furthermore possibility in VTH and RTH. No, in that question no possibility, na? It's just only VTH, RTH and P max, that's it, nothing more can be asked, na? In this particular question they are asking find the Y parameter, na? All. This question has been asked in 2021. 2021. Correct? They are asking about the Y parameter, na? They are asking about the Y parameter. और आपके सिद्धार्थ सर यहाँ दिखाई दे रहे हैं. वाओ सर. सर अभी अर्थ और सर अभी अर्थ वर्थ लेके आ जाएंगे. चंद्रमा अर्थ मून लेके. Okay. Now what is asking? They are asking about करके चैंपियन बन जाऊंगा. क्या बात है. चलिए आइए. They are asking about the Y parameter in this particular question. Then I have told you already, whenever they are asking the complete parameter, whether it is Z or whether it is Y, you always think about the what? Conventional approach. You always think about what? Conventional approach. That is simple KVL KCL. That's it. So now you see, if you want to calculate the Y parameter in this particular circuit, what we will do? We will apply simply the conventional approach. For Y parameter, what is needed? We need I1 is equal to I2 is equal to Y11 V1 plus Y12 V2 Y21 V1 plus Y22 V2. Yes sir. Are you getting point? Yes sir. Great. Now Y parameter, Y parameter sir. Now let's see. Now you need to calculate like this one. So you need to develop this kind of equation. You will get the answer. So what I will do, in case of Y parameter, what you will see, this particular voltage is V1. Yes sir. This particular voltage is what? V2. You can see directly at this particular node, you can apply directly the nodal, you will get the answer. It is the reference node. Apply the nodal V1, 1 by how much? 1. Next, plus 1 by how much? 1. This is another resistance, that's cool, minus this 1 is connected with the V2, so V2 divided by 1. Absolutely correct sir. Now tell me the how much current is incoming. This is incoming current, so positive I1. Next one, this is also incoming current, so positive 3V2. Perfect sir. But you can see here, you are getting equation I1, V1 and V2. You need this one to get the parameters. Yes sir. And then you will understand. Okay. See here. Now we have all the things. So we are getting 2V1 minus V2 is equal to I1 plus what? 3V2. So what is the I1 value? I1 we are getting, that is equal to 2V1 minus ka 4V2. Is it okay? Now the first expression is similar to this expression. Now compare with this one. So Y11 we are getting 2 and Y12 we are getting minus 4. So these two things we have calculated by simply using the nodal. Now apply the nodal at this particular node. What you will get? V2 bracket 1 by 1. Next 1 is common with the V1 minus V1 by 1. Now coming to the incoming current is only I2. So I2. So I2 we have minus V1 plus what? 2V2. Now you can see this equation is same as this particular equation. So y21 is how much you are getting? Y21 you are getting -1, and y22 you are getting how much? That is equal to 2 na? So all parameter you have calculated, which option is matching, that will be the right answer for all of you. Are you getting my point? Yes sir, absolutely getting a point sir. Is it okay? Yes sir. Now coming to the next question. See, this question is given as there is a resistor, okay, and there is a voltage source, this one, and there is a 2-port network. Here it is written as the Z parameter is given as, that is equal to 40/60, 60/120, okay, and here they have been marked as ZL na? This is ZL. Here it is written V2 and here it is written I2 na? It is the 10 ohm. It is given as 120 volt, correct, and this is the V1 and this is the I1. Now what they are asking, they are asking the value of ZL for which maximum power transfer. They are asking. Short break of 5 minutes. It's just only 1 hour na? 2-hour class is this one. It's a 2-hour class only. It has become 1 hour only na? Okay beta. Now what they are asking, they are asking about find the ZL to have maximum power na? Maximum power, correct. Now tell me, it is a DC circuit na? So there is no concept of ZL here. Actually this is just to make you confuse. It is written ZL here, but it is saying that RL na? Because it's a DC circuit, so there will be only resistance na? Not impedance na? Is it correct? So actually they are asking about the RL value at which here it will be the maximum power na? You tell me, for maximum power this RL must be variable. Here it is variable, here it is variable. RL we don't know the value. So what I will do, we need to calculate what? RL must be equal to RTH na? That means we need to calculate the RTH value at this particular terminal na? We need to calculate the RTH value at this particular terminal na? Yes sir. So how we will do that? See here how we can do that thing na? So what is the, how you will know that which case I have to apply here? You tell me which case I have to apply here. Case 1, case 2, case 3, case 4. We cannot figure out na? Because we don't know about the what kind of structure in this particular network na? Inside this particular network na? So we cannot figure out whether it is a case 1, whether it is a case 2, whether it is a case 3, whether it is a case 4, whatever the case will be na? Are you getting my point or not? Yes sir. That means whenever such situation arises, you don't know about which kind of case you have to apply to calculate the RTH value, then always remember only one approach is valid, that is called the test voltage approach. Test voltage approach na? That is only the one approach that validates, that is called the test voltage approach na? Are you getting my point or not? Yes sir, absolutely getting point. What is the test voltage approach? That means you have some voltage here. I'm not taking it 1 volt, you can take it 1 volt also. That means here the RTH will be simply at this particular terminal, the voltage is V2 and whatever the current it is passing, that is equal to I2, means the ratio of V2 by I2. If you take it 1 volt, then 1 volt divided by how much it will become? I2 na? Are you getting my point or not? Are you getting my point or not? Please tell me yes or no. Correct. But while applying the test voltage approach, the independent sources will be deactivated na? So it will become shorted na? Are you getting my point? Yes sir, absolutely getting a point. Is it okay or not? Yes sir.
If you take V2 as a 1 volt, then 1 by I2 na, simply. Now tell me, how we can solve this? We need the ratio of V2 by I2, or simply you need to calculate the I2 current na. What I can do, see here, we have one Z relation here na. If we have a Z relation here, then for this two-port network, I can write down V1 is equal to 40 I1 plus ka 60 I2, and V2 is equal to 60 I1 plus ka 120 I2 na. Yes sir, it will be there. Yes sir, absolutely it will be there na. If it is there, what will happen? See here, this is given to us na. Now you can see, if you want to take at V2 as a 1 volt value na, if you want to take it as a V2 is equal to 1 volt value, there is no problem, you can take it na. If you don't want to take it, you need not to take it, your choice na, because in universal approach, test voltage approach, you take 1 volt or you take V voltage, we take 100 voltage, you can take 1000 voltage, there is no problem. If you want to take it 1 volt na. So I am taking it 1 volt, so 1 is equal to 60 I1 plus what? 120 I2 na. Correct? Here we are getting these two relations na. Now we need to calculate the I2 current na. Can I get, here we are seeing that there are three variables na. I1, I2, V1, three variables. We have only two equations. Need one more equation. You can see this current is I1 na? Yes sir. So plus minus this one be, apply the KCL, you will get V1 is equal to minus 10 times of I1 na? Absolutely correct sir. This is the V1 value na. So what I will get? I will simply get it, just put it here, V1 minus 10 I1 is equal to 40 I1 plus ka 60 I2 na. Absolutely correct sir. So this will become 50 I1 plus ka 60 I2 is equal to 0. Can I take it out 10? So 5 I1 plus ka 6 I2 is equal to 0. This equation and see this equation, take it 10 out. So what we will get, 6 I1 plus 12 I2 na, is equal to 1, or we can say I1 that is equal to 2 I2 is equal to how much? 1. It's no, sorry, like this one na. Okay, this is the equation number 2. Just solve these two equations. What I will get? 6 I1 plus 12 I2 is equal to how much? 1. 1 by 10. Sorry. 10 if I am taking out, take it directly this one na. Why I'm just taking out 10 na. 60 I1 plus 120. Take it 60 I1 na. 60 I1 na. 60 and 120. This is 1 now na. Okay. Because if you take 10 out, then here it will be also 10 na. 5 I1 plus 6 I2 na, plus 6 I2 is equal to how much? 0. We have these things na. Now tell me, we need to calculate which current? I2 current na. So just neutralize I1. So what I will do? Just multiply 5 with that quantity, that it will become 16 na. It will become 16 na. So how much I have to multiply? Tell me. 12 na. If you multiply with the 12 this particular equation, what will happen? Then subtract it. This will be cancelled out. Here it will become I2 120 minus 6 into 12 is equal to 1. This will become I2 is equal to 1 divided by 120 minus 120. I'm just writing it, 120 minus 6 into 12 na. So what I'm getting? 48 na. This is 48. This is 48. I2 value this one. So 1 divided by I2 is equal to how much? This will become 48, and this is equal to RTH na. So RTH will come out to be 48. 48 na. I think 48 it is coming. Let me check the answer. I think 48 it is coming na. 48 is the right answer. 48 is the right answer for this particular question. Yes, It is given 48 is the right answer. It's a 2020 problem. Na? It's a 2020 problem. No, how you have calculated? I have explained each and everything. Na? I have written these two equations from this one. Then after I have written one equation from here. That's it. I have taken the test voltage approach. So I have connected here 1 volt source. That's it. Correct. 48 ohm will be the right answer for this particular question. Are you getting my point? Yes, sir. Absolutely getting a point. In this way, you need to calculate everything. Na? You have to calculate the everything. Na? Now, if somebody is asking, what about the VTH value? What about the VTH value? You can also calculate VTH value. Then what will happen? You have to make that terminal open circuit. That means you need to make I2 is equal to 0. If you make it I2 is equal to 0, then only you can calculate the value of VTH. Na? You need to focus on you have to make it I2 is equal to 0. Na? I2 will become 0. Na? Absolutely correct, sir. If you make I2 is equal to 0, then only you can calculate things. Na? Correct? See, coming to the next one. Na? Coming to the next question. What is the next question? See here. What is the next question? They have given, see here. They have given, there is a network. There is a network. Na? Exactly. In this network, it is written as network. And here there is a resistance. And here there is a voltage. Like this one. And here there is another resistor like this one, and it is written here plus minus V2, and this current is I2, and here they have written as V1, and this current is equal to I1, and here it is 100 volt, and here it is given 25 ohm. Correct? And here Y parameter of this particular network is given, that is equal to 0.1 minus 0.01, 0.01, 0.1 Siemens. Na? Then they have asked find the V2 by V1 question mark. Is it correct? Yes, sir. They are asking about this particular question. Na? That V2 by V1, it's a gain, I guess they are asking. Na? They are asking about the gain. Okay, fine. We will see V2 by V1 simply. Na? They are asking V2 by V1. Okay. Check this question. What is the R value? R value is given 100 ohm. Sorry. 100 ohm. It is 100 ohm given. Na? Now see, you need to calculate V2 by V1. Here nothing, condition is not given. Condition is not given that make it 0, then after you calculate it. Na? Nothing is given to you. I don't think so there is any condition is given. No. No condition is given in this particular question. I am again checking from different book. No, there is no condition is given in this particular. Na? Correct? So what is happening? See here. Yes, dear. Yes, yes, Gayatri. See here. V2 by V1 you need to calculate. Just forget about this one. Just think about this 2-port network and circuit. Na? Just think about this 2-port network and circuit. Now, first of all, I will write down the equation for this one. Na? So what will happen? I1 is equal to 0.1 into V1 plus minus 0.01 into V2. Na? Perfect. I2 is equal to 0.01 V1, and this will be plus 0.1 V2. Na? Perfect, sir. Is it correct? Yes, sir. Absolutely. It is given to us. Na? Now tell me, these two equations I can find out. Na? Now, but we need more equations. Na? One equation we can see, if it is I2 current, then this voltage will be how much? This voltage will be 100 into I2, though V2 is equal to minus 100 I2. Na? Perfect. V2 we can get it minus 100 I2. Na? Absolutely correct, sir. So we have everything now. Na? We have everything now. Okay. See here. If we have this particular V2 value, just see here in this expression. In this expression, we have V1, V2 and we have I2. Na? Just put it I2 value here. Na? So what I will get? V2 divided by negative 100 is equal to, how much we are getting? 0.01 V1 plus 0.1 V2. Na? So this will become minus 0.01 V2 is equal to 0.01 V1, and take this side. Na? So what will happen? Minus 0.1 V2. Correct? So how much it will be? It will become 0.1, 0.01. 0.1 plus 0.01. You are getting negative 0.11 V2 is equal to 0.01 V1. So what is the value of V2 by V1 is equal to, we have got it, 0.01 divided by negative 0.11. So taking inverse into 0.01, I think we are getting negative 0.090. This must you are getting also? This must you are getting also, beta? Please tell me. I think this must, we are getting the answer. We are getting the answer here. The answer is given to us. It is given 1 by 11. 1 by 11. Yes, we are getting the same answer. It's absolutely correct one. Minus 1 by 11, or we can say that minus 0.090 will be the right answer for this particular question. So hopefully you have just understood that whenever you see the question, don't get afraid of that particular question. That means that question is not going to kill you. That question is going to help you out. Okay. So coming to the next one. See, coming to the next question. It is given that, see here, it is given that there is a switch and there is a resistor and there is a voltage source like this one, and there is a 1 ohm resistor, and here we have another inductor like this one, and here we have voltage source like this one. The values are 0.5 Henry, and this current is given as IL. This is 1 ohm. This is equal to 30 volt. This is equal to 4 ohm. This is equal to 10 volt. And here the switching action is given to us. This is T is equal to 0. Correct? See what they are asking now. Please note it down. This question has been asked in 2021. 2021. Correct? They are asking, find the value of ILT for T greater than equal to 0. They are asking about the ILT value, that means inductor current. So let me correct you. I have already told you that whenever you see the question on the transient analysis, always first think about the order of the circuit after switching. If you see, after switching, the order of the circuit is only 1. So order of the circuit is 1. First thing we have generalized? Yes. If we know the order of the circuit, now things will be very easy. If we have the order of the circuit, then any voltage or current can be written directly. How? ILT will be written as IL steady state plus IL instant of switching is 0. So 0 plus minus IL steady state e to the power minus t by tau. This equation is absolutely valid. This equation is absolutely valid. Na? Absolutely correct, sir. Now we need to figure out all these values. Na? What I have told you, whether they are asking t greater than 0 or t is equal to 0 plus whatever, 0 minus you need to calculate. Na? So first I will calculate at t is equal to 0 minus. Now inductor will be short circuited. Switch is what? Closed. Na? Switch is closed, not 0 minus. It is opening at 0. So before it will be closed. Na? So what circuit you will get? We will get this kind of circuit. Na? We will get this kind of circuit. Na? You can see this kind of circuit we are going to get it. Na? This switch will be closed and this will be shorted. Na? Yes, sir. So this is closed. Na? Now this will be shorted. Make it short. Make it short circuit. Na? So tell me this current IL 0 minus. Na? Now tell me how you can calculate it. Very clearly you can see. You have seen that this particular voltage will be 0 volt. So this is this current IL 0 minus. IL 0 minus. Na? Okay. This will be plus minus this. Can I apply the KVL in this loop? Yes, sir. If you apply the KVL, minus plus voltage, this is 0. This is plus minus drop. So 10 is equal to, how much you are going to get? 10 is equal to, you are going to get IL 0 minus into 1. So IL 0 minus, you have got it 10 ampere. Na? Correct? It's getting 10 ampere. Na? Absolutely correct, sir. Chapter 1 is always Basha. Now tell me, if IL 0 minus this one, that means IL 0 plus is also will be equal to 10 ampere. Why it will be 10 ampere? Because inductor current at 0 minus 0 plus will remain what? Same. So need not to calculate the second stage. Na? Now coming to the next one. At t is equal to steady state. Na? Switch is now open. And inductor is again short circuited. So what circuit you will get? Switch is open. This will be the circuit will become. There is a resistor. It is again shorted. Like this one. And here it is a 10 volt. Na? And this current will be IL infinity. Na? This is 1 ohm. Correct? And this is the 4 ohm. This is the 30 volt. Na? If it is open, then the same current will flow here also. That will be IL steady state. Na? So simply apply the KVL again. Apply the KVL. What you will get? Minus plus voltage, minus plus voltage. So IL steady state will become 40 divided by 4 plus 1, 5. Na? 8 ampere. Na? Yes, sir. This is you are getting 8 ampere. Na? नीचे वाले में KVL लगाया तो नीचे वाले में if you want to apply the KVL, then you think about, you know this current. Na? You don't know this current. Na? Then why are you making complicated? If you can see, if it is shorted whole terminal A to B, if you take it, then here also A to B, then here also this will be, overall voltage will be 0. Na? Then why I will apply in this one? If you apply here, you need one more current. It will become little bit lengthy. Na? That's it. Or you need one more current here also. Na? Because you know this current. Na? You don't know about this particular current. Na? But you know this voltage. Na? Are you getting my point, beta? Alok Mishra? Okay, great. So this is 8 ampere. Na? Now coming to the last and final calculation. That is the time constant calculation. That is the time constant calculation. So what is the time constant? I have told you, after switching, switch is open. We need to calculate first R equivalent here. Na? This is R equivalent, na? RTH or R equivalent. Tell me which case it is. Case number 2. It's a case number 2 problem. Na? There is a voltage source. There is a voltage source. Make it short. Make it short. Make it short. Na? Yes, sir. If you make it short, then tell me 4 ohm and 1 ohm in series, na? So R equivalent will be 4 plus 1, that is equal to 5 ohm. Na? So time constant will be equal to L equivalent is how much? L equivalent is how much? L equivalent we have 0.5 Henry. Na? 0.5 Henry divided by R equivalent is 5. So you will get the value of time constant. That means 1 by tau is equal to how much you will get? 5 divided by 0.5. That is equal to how much? 10. Na? Correct? Correct, na? Yes, sir. 1 by tau is equal to 10. Na? So ILT expression will become what? IL0, how much you are getting? 10. Sorry. 8 plus 10 minus 8 e to the power minus t into 1 by tau. So direct I will write down 10. Na? So the answer will be 8 plus 2 e to the power minus 10t. Na? This much of the ampere of current will be for the ILT, and this will be the right answer for this particular question. So hopefully the options were given and the right option I have chosen, and that right option will be 8 plus 2 e to the power minus 10t. Na? Is it correct or not? Yes, sir. Absolutely correct, na? Yes, sir. Now coming to the next one. Coming to the next one. Here there is a voltage source is given. Voltage source is given like this one. This is resistance and this is the inductor. Na? Yes, sir. Here there is a switch also given. It's written as S2. And here there is a resistance and there is a voltage. Na? This is 3 volt. This is also 3 volt. And this is like this one written as S1. And here 1 Henry. And here it is 1 ohm. And here it is 2 ohm. Na? Now see here. It is saying that at t is equal to 0, S1 is closed. Na? S1 is closed. It is written at t is equal to 0, S1 closed. Na? S1 closed. Okay, fine. S1 closed. Then it is asking the rate of change of current through the inductor. This current ILT, it is asking DILT by dt, rate of change of the current at t is equal to 0. They are asking this particular question. They are asking this particular question in this particular circuit. Okay. Rate of change of current they are asking. Okay, fine. Now you tell me how you calculate the rate of change of the current in inductor. See, whenever you have to calculate the rate of change of the current, you know that for an inductor, if it is VLT, tell me, you tell me. If it is VLT, you tell me. We know that na, VLT is equal to DILT by dt into L. Na? Yes, sir. So DILT by dt, we can write down VLT divided by L. Na? If they are asking about DIL by dt at t is equal to 0 plus or 0, then we have to calculate VL at 0 plus divided by L. Na? That's it. We need to calculate the voltage at 0 plus this particular voltage. Na? Correct? Yes, sir. Absolutely correct. What about this switch has been given? It is permanently closed. It is permanently closed. Na? Nothing is written about this S2. Na? That means it is permanent closed. Okay. This switch has been given just to make you confused. That's it. Okay. So what I will do, first of all, we will do, to get the value of 0 plus condition, we need to calculate 0 minus condition first. Na? At t is equal to 0 minus, at t is equal to 0 minus, what will happen? The S1 switch is open, this is open, This is permanently closed. And here what we will get? We will get the current as IL0 minus, and this voltage will called as VL0 minus. Correct? How much it will become? If this switch is open, this current will remain same, IL0 minus, and IL0 minus will become 3 divided by, apply the KVL. This is shorted, na? This is shorted, na? Sorry. This is shorted, na? This is short circuited, na? L will be short circuited, na? Yes, sir. So 3 divided by 2, na? 1.5 ampere. And this value will also be equal to IL0 plus. Correct, na? Yes, sir. That is also equal to IL0 plus, because inductor current at 0 minus and 0 plus will remain same, na? Yes, sir. Now tell me, we have now this value, na? Okay. What I will do? Now at t is equal to 0 plus condition. Now t is equal to at t is equal to 0 plus condition. What will happen? What I have told you? At t is equal to 0 plus, at t is equal to 0 plus, at t is equal to 0 plus, inductor will be replaced by the current source. Na? Yes, sir. Correct? What is the switch? S1 is now closed. Na? At t is equal to 0, it is getting closed. Na? Okay, this is closed. This will be replaced by a current source. Na? Yes, sir. Like this. How much value? Whatever the value you have calculated, IL0 plus. How much value you have calculated? We have calculated 1.5 ampere. So this will become 1.5 ampere. And this voltage is known as VL0 plus. Na? Across this inductor, it was the voltage. Now the switch is closed. Now tell me, you have to calculate this particular voltage. Na? How you can calculate this particular voltage? Now just apply the KVL and KCL. That's it. Whatever you can do, that's only the KVL and KCL. Na? So what I will do? Or we can do this particular question in one go without doing KVL KCL by using the nodal analysis. Na? In one go. Na? Why? Because there we have only one node. Na? So we can write down directly the nodal VL 0 plus 1 divided by 1, 1 divided by 2. Correct? There is no other principal node. Correct? Is equal to, this is outgoing current minus 1.5. This is plus 3 divided by 2. And this is 3 divided by 1. 3 divided by 1. So VL0 plus we can directly, this will become VL0 plus into 1.5 is equal to, this is 1.5, this is 3. 4.5 minus 1.5, 3. Na? This will become 3. So VL0 plus you will get 3 divided by 1.5. So this will become 2 volt. Na? That's it. This will become 2 volts. Na? Up, if it is 2 volt, then tell me, DIL 0 plus by DT will become now VL0 plus by L. Na? VL0 plus we have got it 2. L value is how much we have got? L value is given to us. Na? That is called 1 Henry. So 2 by 1 ampere per second. So ampere per second. This must be the right answer for this particular question. So 2 ampere per second will be the right answer for this particular question, in my opinion. Let me check this one. Where is the question? 2. 2 is the right answer. 2 ampere per second is the right answer for this particular question. Okay, great. Now coming to the next one. It is given here, there is a 5 volt. There is a 5 volt and there is a resistor. Okay, and there is a switch and there is a capacitor like this one, and there is another resistor. This is 4 ohm and it is given as 1 farad. It is given as 1 ohm and it is given as switch is like this one, t is equal to 0. Correct? Now they are saying at t is equal to 0 plus, find the at t is equal to 0 plus, find the current in capacitor. Current in capacitor means this current, ICT. Okay, IL after differentiate can be calculated here. IL, then you need to calculate the ILT first, then differentiate it, then after put t is equal to 0. Definitely you can do it, but for that you need to calculate ILT first. So if you want to calculate ILT, then what will happen? You need to calculate the 0 minus, you need to calculate the steady state, you need to calculate the time constant. So it will be more complicated na beta Arpit Mishra, it will be more complicated na. So better, what is the best option? We have just calculated this one, that is simply the 0 minus and 0 plus condition, and we have just put it, we have got the answer. Okay, so make things easy, not complicated in any way. Okay, now see, in this particular question, find the current in capacitor at t is equal to 0 plus. So again the question is same thing. First what we will do, we will calculate at t is equal to 0 minus. At t is equal to 0 minus, what is happening? At t is equal to 0 minus, switch is what? Closed. Capacitor will behave as an open circuit. Make it open. Make it open. Switch is closed. Closed. Capacitor is this one and this is the voltage VC 0 minus. Correct? Now you can see these two resistance will be in series. So VC 0 minus you can directly calculate with the VDR. 5 into 4 divided by 5. That is equal to 4 volt. So this has come out to be 4 volt. Correct? Yes, sir. Now coming to the at t is equal to 0 plus. It's a very easy question. T is equal to 0 plus. At t is equal to 0 plus, what will happen? Switch is now open. Switch is now open. Tell me. Switch is now open. Open. Correct? The capacitor will be replaced by what? The capacitor will be replaced by what? A voltage source. How much? 4 volt. Yes, sir. Now this current is known as what? IC 0 plus. Perfect. Is it okay? Yes, sir. Now tell me, if it is 4 volt, this voltage will also be 4 volt. So this current will be 1 ampere. Now you see, if it is 0 ampere current, then at this point you see this is outgoing also. So IC 0 plus is how much? Minus 1 ampere. Done. IC 0 plus is what? Minus 1 ampere will be the right answer for this particular question. IC, this will become, the answer will be minus 1 ampere. I am getting minus 1 ampere. Now they have given the answer 1 ampere. They have given the answer 1 ampere. You see, if you take it 1 ampere, then they need to give the direction of current also. But in the circuit, there is no direction of the current has been given. I have taken this direction. So if they have given the direction, then only you can take in that direction. According to my direction, it is coming to minus 1. So I will take it minus 1. If they are saying that no, you need to calculate the upward direction, then take it the upward direction. Or if they have asked about the magnitude of IC current, magnitude, if they are asking, then you can directly write down the only magnitude. Only magnitude. Is it correct or not? Yes, sir. Absolutely getting a point. And you need to understand, in this way you have to tackle the things. Otherwise things will become complicated. It will become complicated and then definitely things will be in a wrong approach. things will be in wrong approach. Okay? Okay, is it fine? Is it fine or not? Okay, great. So one question I can see here like this one. Yes, I am seeing here. Sometimes this kind of question has been asked. See, sometimes this kind of double switching questions will be done in the Mahabhyas, 7 p.m. Okay, we will do that in Mahabhyas, na beta? Not here, na? Not here. Okay, here it is given. Sometimes the AC circuit questions will be very easy questions that has been asked in the examination in PYQ. What I can see, there is a resistor and there is a inductor. Okay, there is an inductor like this one, and there is an inductor also, and there is a capacitor also. Great. This is given C, this is given J5 ohm, this is given J5 ohm, this is given J5 ohm, na? And this is given 10 ohm, and this is given 10 volt, 10 volt, and here omega is equal to 5k radian per second. What they are asking, this is very popular question. Okay, this is very popular question. Okay, see here, this is the I current. See, it is saying that find the value of C, find the value of C so that I current will become 0 ampere. I current will become 0 ampere. Are you getting one? What they are asking? They are asking something. I think this is the only question they are asking. Na? Yes. They are asking find the value of the C at which the I current will become 0 ampere. Good question. See, first thing, let me see. Whenever the current will become 0 ampere, just think about, na? Just think about. Whenever the current will become 0 ampere, whenever the current will become 0 ampere, you tell me in any circuit, whenever it will become 0 ampere, when there will be an open circuit, na? Tell me, when there will be an open circuit, na? Yes, sir. When there will be an open circuit, then only the current will become what? 0 ampere, na? Open circuit, na? If this is the current, can I say that at this terminal A and B, if you found the ZAB bar, then this ZAB bar must be equal to infinity. Must be equal to infinity. Are you getting my point or not? Must be equal to what? Infinity. Then only the current will become 0. So what I can do? I can just calculate the Z equivalent of this circuit. So Z equivalent, how you can calculate the Z equivalent of this particular circuit? What will happen to Z equivalent to this particular circuit? This is the minus JXC. Yes, sir. Absolutely correct, sir. This is the minus JXC. Yes, sir. Now you tell me, if you want to calculate ZAB, what will happen? These two are in series. That means this will become J5 minus JXC. Yes, sir. Correct, na? Absolutely correct, sir. Next, this will be in parallel with this one. So what will happen? Here it will become, let's take it Z1 bar. Na? So Z1 bar will be equal to J5 multiplied by J5 minus JXC divided by how much? J5 plus J5 minus ka JXC. Na? This is the Z1 bar till this one. Na? Now again, what will happen? To get the ZAB bar, this will be added. This will be added, na? This will be added. 10 plus J5. Okay. Now don't make it complicated. What more? More we can think about now. In this one, there is no portion of C. Na? If you are saying if ZAB is infinite, then I is equal to 0. I can also say that na, if Z1 bar is also infinite, then also this current will be what? 0 ampere. Na? Because Z1 bar and this quantity is in series. Na? If this is infinite, then this will also become the infinite. Na? Tell me na, if this is infinite, if something you are adding, this is infinite and you are adding something in this infinite, then also the current will become 0 and ZAB will also become what? Infinity. Na? Yes, sir. So can I say that this is ZAB bar, na? And this is Z1 bar. So Z1 bar, put it infinity, because we have the, don't make it complicated, otherwise I have to take the LCM, then making this like this one, so it will become complicated. Now we have the separate this equation. Na? So what I can do, this just make it infinity. Na? So what will happen? J5 into J5 minus JXC divided by J5 plus J5 minus JXC is equal to what? Infinity. Na? Correct? Yes, sir. Now solve everyone and tell me the answer. Everybody please solve and tell me the answer. Everybody please solve and tell me the answer. Everyone please solve and tell me the answer. Tell me the answer now. Now you can give me the answer. Na? Tell me. X is equal to 10. Simply, you see here, J5 minus JXC. See na? This is J10 minus JXC. This one. You need to make it infinity, this quantity. Now, if you make it 0, this will become infinity. Na? Obviously. So what I can say, J10 is minus JXC is simply is equal to 0. So XC you have got it 10. Na? And XC is equal to 1 by omega C. Na? So 1 by C is equal to how much you will get? 10 into omega. Na? So C value is equal to how much you will get? 1 divided by 10 into omega. Na? That's it. Correct? And omega is given to a 5K. So 1 by 10 into 5000. Na? Correct? So the answer will be how much you are getting? 1 divided by 10 into 5000. Na? So you will get 20 microfarad. Is it correct or not? 20 microfarad you will get the answer in this particular question. Na? In this particular question, 20 microfarad you will get the answer in this particular question. Are you getting my point or not? Yes, sir. Yes, sir. Now, all the English aspirants, I will request you at 7 p.m. must attend the Abhyas series on the GATE channel also, because more and very nice questions I will take there also. There will be new questions also. So if you can understand little bit Hindi, then you can come at the GATE Wala double ECE and CS channel at 7 p.m. I will continue the Abhyas series there also. In PYQ questions, I have discussed all the questions, almost every topic, almost maximum topic I have tried to cover. So here the discussion is not about that I'm just telling you what concept you have to apply. It is just only to make you recall that whatever the concept you have studied, that exactly you can apply, and this kind of question the GATE examination has asked, and you must have the good confidence that you can solve these questions very easily. Na? So at 7 p.m. I will meet again, and I'm requesting all the English aspirants also, please come into that particular session also. We will get a good thing also. Yes, there in that we will do that. Na? in AC power also we will do that, na? Aditya Banerjee, okay? Okay, dear Aditya Banerjee, that's okay. In Abhyas Ridhi, I will take one question on you also, that is AC power related problem, na? Yes, I will take it. Marks nahi aa rahe, wahi discuss karenge beta, wahi discuss karenge, okay? So 7 PM we will meet again at the yes, yes, okay, great. At 7 PM, everybody please meet at the Abhyas session in the gate wala EEC channel also. You will get a good things also. That will be approximately 3 to 4 hours class, na? Rajat Thakur, 3 to 4 hours class, na? Okay, fine, great. Thank you so much.